Let's do some more examples of differentiating the natural log function. Here we're asked to find the derivative of y equals x squared times the difference, 1 minus ln of x squared. This is a product, so we'll have to use the product rule. The derivative of the first factor, x squared, is 2x, and we multiply that times the second factor, 1 minus ln x squared. And we add to that the derivative of the second factor times the first factor. The first factor is x squared, and the second factor contains two terms, 1 and minus ln x squared. The derivative of the first term, 1, is 0. So that only leaves us having to differentiate minus ln x squared. And the derivative of the ln of a function of x is f prime of x over f of x, where f of x is the argument of the natural log function. The derivative of x squared is 2x, and that's over x squared. And because this is a minus ln x squared, we have to have a minus out in front of our derivative. Now we'll simplify the first term by distributing. 2x times 1 is 2x, and 2x times negative ln x squared is minus 2x ln x squared. To simplify the second term, we'll multiply x squared by the fraction negative 2x over x squared. And that gives us negative 2x cubed over x squared. And simplifying the third term, 2x to the third over x squared gives us 2x. So we have 2x minus 2x ln x squared minus 2x. 2x minus 2x cancels out, and that leaves us with our final derivative, minus 2x times ln x squared. Let's take a look at this example. Here we're asked to find the derivative of y equals the ln of 8x. This one looks wonky for sure, but it makes it a little bit easier if we just recognize that our given function is just ln of f of x again. Y equals the ln of f of x, where f of x is the ln of 8x. So y prime is equal to f prime of x over f of x. In the numerator, we need f prime of x. F of x is ln of 8x. Well, this is just ln of a multiple of x. And remember from our previous videos that although this is still an employment of the chain rule, we don't have to use the chain rule to find the derivative of ln of 8x. Ln of any multiple of x is still just 1 over x. So f prime of x is 1 over x. And that's over f of x, which is ln of 8x. Now simplify the complex fraction by multiplying by x in the numerator and denominator. And that gives us our fully simplified derivative of 1 over x times ln of 8x. Let's do one more. Here we need to find the derivative of y equals ln of 6 cosine to the 6th power of x. In this example, our f of x is 6 cosine to the 6th power of x. And the derivative of this function, y prime, is equal to f prime of x over f of x. We're going to need the derivative of 6 cosine to the 6th power of x. To get that, we're going to have to use the chain rule. Let's let u equal cosine of x, and that means u prime is equal to negative sine x. If u is cosine x, that means y is 6u to the 6th, and y prime is 36u to the 5th. And using the chain rule, the derivative of f of x is equal to u prime times y prime. U prime is negative sine x, and we multiply that by y prime, which is 36u to the 5th. Simplifying that gives us negative 36 sine x times u to the 5th. And now wherever we see u, we substitute back in cosine x. So that gives us negative 36 sine x times cosine to the 5th of x. And that expression is the numerator of our derivative. So now all we need is our denominator, f of x. Well, f of x is 6 cosine to the 6th of x. Simplify negative 36 over 6. and cosine to the fifth of x over cosine to the sixth of x. That gives us negative 6 sine x in the numerator over cosine x in the denominator. And last but not least, sine x over cosine x is tangent x. So our final simplified derivative is minus 6 times tangent x.